Here's our second example of embedded triangles. Again, you have to draw one big triangle, one little triangle, and try to set up the relationship. So I'm just going to take this triangle and flip it around so that I'm looking at something like this. I've got a triangle here. I'm going to call this triangle WXT. WXT. Now when I do the next one, I have to follow that same orientation. So since I want WXT on this, when I go bigger, I'm going to go QXM. In other words, Q should be the same spot where W was. So I put a Q here. The summit angle, the top of the triangle, is still going to be X. And then over there, that'll be M. As I set this up, I look at the base here. It's telling me that this is a Z minus 3. The bigger base is 7Z plus 2. And then I have to worry about this XT side. The XT is going to be over here. I'm going to call that 4. Well, the next one, it didn't give me the whole length here. It gave me it as 2 sections. Now, fortunately, these are easy numbers, and you should be able to reason through this. If this is 4, and from here to here is 8, that means that the whole thing must be 12. And that 12 is what I'm going to put here. Now I can set these proportions up. There's really only one to set up. I can take the right-hand side to the base as the right hand is to the base, or I can try to set those numbers up. Again, I like to work with the numbers because usually I can reduce those. So if I say 12 is to 4, as long as I'm consistent, I'm not wrong, then that would be 7Z plus 2. Since I started with the 12, I still have to start here. 7Z plus 2 is to Z minus 3. As I look at this proportion, I recognize that that number can be reduced for the first fraction. So I'm just going to reduce it to 3 over 1. And as I solve this, multiply by a common denominator, the only thing I'm really worried about multiplying by is Z minus 3. As I multiply that to the first fraction, I get 3 times Z minus 3. To the second fraction, that drops out, and this would just be equal to 7Z plus 2. That should be a nice one to solve. As I solve this, we can say 3Z minus 9 is equal to 7Z plus 2. Move my 3Z to the left. I'm going to move the 2 to the right. Uh-oh. I see another problem. Negative 9 minus 2 is equal to 7Z minus 3Z. Do you recognize what the issue is going to be? I'm going to have another negative answer. So negative 11 is equal to 4Z. That means that Z is equal to negative 11 fourths, which is negative 2 3/4. Again, this will not happen on the test because I just threw these problems together and tried to solve them. Sometimes we get these strange results. Obviously, when I try to find these sides now, I'm going to have negative answers, which doesn't make any sense whatsoever. Your answer should always be positive. If I say Z minus 3 here, that would be negative 2 3/4 minus 3, which would be negative 5 3/4. For the second one, I think I'm going to have to use my calculator for that. And so I'll say negative 2 3/4 times 7 plus 2, and my calculator tells me negative 17 1/4. Negative 17 1/4. Crazy set of answers there. We wouldn't expect negative answers. For the homework, you should scratch your head if you get negative answers. On the test, it will not happen when you're doing proportions because you have to get positive answers, and I will double check those before I write your test.